Okay, so you know how your phone has like storage, right? Like built in.
Yeah.
It's got a place to keep all your photos and apps and all that.
Right.
Well, on today's deep dive, we're gonna kind of take a step back and look at some other ways, bigger ways that data gets stored. And specifically, we're going to talk about SAN and NAS storage.
Okay.
And, you know, this is kind of like if you wanted to know just enough about SAN and NAS to be dangerous without having to, like, go get a network engineering degree.
Right. Yeah. I think the goal here is to really give you a solid foundational understanding of what SAN and NAS are about.
Okay.
So we're going to do that by relating it back to something you're already familiar with, direct attached storage, or DAS.
Okay.
And we're going to go through kind of like what it is and also hint at why it is the way it is.
Okay.
And this is all based on a really insightful lecture that I recently came across that I think explains these concepts pretty well.
Okay. Well, let's unpack this then.
Sure.
So to get started, let's just think about a regular computer
Yep.
or a server.
Right.
Like, you got your desktop or you've got a server that's, running a company's email or something like that.
Uh-huh.
What are the fundamental parts of a computer that handle information?
So at the heart of every computer or server, you've got the motherboard, which acts as the central nervous system connecting all the various components.
Okay.
And then you've got the CPU, the central processing unit.
Right.
The processor, which is basically the brain of the computer, responsible for all calculations and operations.
Uh-huh.
And when the CPU is actively working with data, it needs a really fast temporary storage area.
Right.
And that's the role of memory,
Yeah.
or what we often call DRAM.
Dynamic random access memory.
Exactly.
Yeah.
And DRAM is super fast. That's why you can open applications quickly and your computer feels responsive.
Yeah. And it's that working space.
Yeah, it's like the CPU's workbench. But here's the thing about DRAM. It's volatile.
Right. Meaning that when the power goes out, whatever's in there is gone.
Exactly. As soon as you cut the power, poof, the data in DRAM disappears.
Right.
So for anything you want to keep long term, you need a different type of storage.
Right. A more permanent storage solution.
And that's where hard drives or solid state drives come in.
Yeah. So that's like the long-term memory of the computer.
Precisely.
Okay.
They are much slower than DRAM,
Right.
but they can store a massive amount of data. And crucially, they retain that data even when there's no power.
Right. So it's this trade-off, right?
Exactly. You trade speed for permanence.
Yeah.
DRAM is like your short-term memory, fast but fleeting. Hard drives and SSDs are like your long-term memory, slower but much more persistent.
Okay. And then there's that, that part of the computer that allows it to talk to other computers, right?
Yes, that's the network card.
Yeah. So whether you're, surfing the web or accessing files on a shared drive, that network card allows your computer to communicate with others over a network.
Exactly. And of course, there are other components in a computer, things like a graphics card. But when we're talking about storage, those aren't really part of the picture.
Right.
It's really about that interplay between CPU, memory, and hard drive, and then that network card for getting data in and out of the system.
Right. And it's not just the physical hardware either.
No, you're absolutely right.
Right. You've got to have the software that makes it all work.
Exactly.
Right.
That's the operating system.
Yeah, like Windows or Mac OS on a personal computer.
Right. Or maybe a server-specific OS.
Right.
And then on top of that, you've got the applications.
Yeah, all the programs and stuff that people actually use.
Exactly. So all this software interacts with that hardware to actually manage your data.
Right. So when we think about all those pieces working together, this brings us to DAS.
Yes, direct attached storage.
So in its simplest form, DAS basically means each computer has its own dedicated storage.
Right, directly connected to it.
Right. So that could be the internal drive in your laptop
Uh-huh.
or, an external drive that you plug into a USB port on your desktop.
Exactly.
And that storage, it belongs exclusively to that machine.
Right. It's like each computer having its own private storage locker.
Right.
Now, it gets interesting when we think about how this plays out in the world of servers.
Okay.
So you've got something like, say, a Dell-powered server.
Okay.
They often have these drive bays built right into the front of the server.
Right. So you can install hard drives directly into the server itself.
Exactly. That's direct attachment.
Okay.
Now, you might also have these external enclosures filled with drives that connect to that server.
Right. Sort of expanding the storage capacity of that one server.
Exactly. But the key point about DAS, whether it's internal or external, is that these enclosures are just, well, dumb boxes of drives.
They don't have their own processing power.
No, they don't.
They don't have their own memory.
Well,
They rely entirely on that connected server to manage them.
precisely.
So the external enclosure is not like a computer on its own.
Right.
It's just an extension of the server's storage.
It's like adding extra shelves to your storage locker,
Mm-hmm.
but you still need to go through the same door to access everything.
Exactly.
So that's DAS.
Okay, so that's the landscape of direct attached storage.
Yes.
Now let's kind of step into a different world.
Okay.
Let's talk about SAN and NAS.
Shared storage.
Yeah.
This is where things get really interesting.
Okay.
So if DAS is all about one computer, one set of storage,
Right.
SAN and NAS represent this shift towards a more shared resource approach.
Okay.
Imagine a centralized pool of storage
Okay.
that multiple computers and servers can access simultaneously over a network.
Okay, so we're talking about a centralized storage system.
Exactly. That's the core idea.
Okay.
And the terms SAN, which stands for Storage Area Network,
Okay.
and NAS, Network Attached Storage,
Right.
essentially describe the different methods,
Okay.
different protocols or sets of rules, if you will,
Okay.
that are used to access that shared storage.
So SAN and NAS, these are kind of like the different languages.
In a way, yes.
That computers use to talk to these shared storage systems.
Yeah, that's a good analogy.
Okay.
Now, we're not going to dive deep into the technical weeds of these protocols today,
Right.
but it's helpful to know that they exist.
Right. They're like the highways and byways that the data travels on.
Exactly. Think of SAN protocols as being like super efficient freeways for moving large chunks of raw data,
Okay.
often used for things like, big databases or high performance computing.
Okay.
Whereas NAS protocols are more like the regular roads you might use to share files between computers on your home network.
Okay, so different protocols for different purposes.
Exactly.
Okay, got it.
And if we tie this back to our earlier analogy of storage lockers,
Okay.
DAS is like having your own personal toolbox that only you can access.
Right, my own private stash of tools.
Exactly.
Okay.
But SAN and NAS are more like a shared workshop
Okay.
with specialized tools that everyone on the team can use whenever they need them.
Okay.
And that shared access, that's a key advantage. And we'll get into why that is later on.
Right. Okay, that makes a lot of sense. So we've kind of looked inside a regular computer.
Yes.
We've seen how DAS works.
Okay.
Now let's take a peek inside one of these SAN or NAS systems.
Okay.
And you might be surprised to see some familiar components in there.
Right. What's fascinating is the parallels to a standard server.
Okay.
A SAN or NAS system also has a motherboard,
Okay.
acting as the central connection point for all its parts.
Okay, just like a regular computer.
Exactly.
Got it.
It has a CPU to handle all the processing tasks.
Okay.
It has memory, DRAM, for fast data handling,
Mm-hmm.
and it has at least one, if not several, network cards, so you can communicate with the other devices on your network.
Right. So it's basically a specialized computer designed for storage.
Exactly.
Okay.
Now, all those core components, the motherboard, the CPU, memory, the network card, they're all integrated into a single dedicated unit.
Okay.
And that unit is typically referred to as the controller, or sometimes the head of the storage system.
Okay, so the controller, that's kind of like the brains of the operation.
Exactly. It's the heart and soul of the storage system, managing all the operations.
Okay.
Just like the CPU manages things in your computer.
Got it.
But the primary purpose of any storage system, of course, is to store data.
Right.
Right. And that's where the disk subsystem comes in.
Okay.
So this is simply the collection of hard drives or solid state drives.
Right.
Where all the bits and bytes actually live.
The actual storage media.
Exactly.
Okay.
Now, this disk subsystem, it can be physically located in the same enclosure as the controller,
Okay.
or, especially for larger storage needs, it can be housed in separate external boxes called disk shelves.
Right.
So you might have a controller unit that's connected to multiple disk shelves, which are essentially just racks of hard drives.
Okay, so we're talking about potentially a lot of drives here.
Oh, absolutely.
Okay.
And just like your computer needs an operating system,
Right.
a SAN or NAS system also has its own specialized OS.
Okay.
And this software lives on the controller.
Okay.
And it basically acts as the conductor of the orchestra, managing all the requests coming in from the network,
Right.
controlling how data is written to and read from the disks,
Mm-hmm.
keeping everything running smoothly.
So it's like the traffic cop for all the data coming in and out of the storage system.
Precisely. Now, here's an interesting point.
Okay.
These aren't the typical operating systems you see on a PC.
Right, like Windows or Mac OS.
Exactly.
Okay.
Instead, these storage systems run specialized proprietary operating systems
Okay.
that are created by the companies that manufacture the hardware.
So companies like NetApp, Dell, EMC, IBM.
Precisely.
Okay.
And these operating systems are designed specifically for managing storage. And they often include all sorts of advanced features like, for instance, deduplication.
Deduplication, that sounds interesting.
Yeah, it's a clever way to save space.
Okay.
It basically eliminates duplicate copies of data.
Oh, so if multiple users have the same file stored,
Exactly.
it only keeps one copy on the disk.
You got it.
That's pretty smart.
Yeah, it's a great way to optimize storage efficiency.
Okay.
And then there's also compression.
Okay, so that's like zipping up files to make them smaller.
In a sense, yes.
Yeah.
It's about shrinking the data down so it takes up less physical space on the drives.
Okay, so these features are part of the reason why you might choose a dedicated storage system.
Exactly.
Okay, so we've got this controller, the brains,
Yes.
and the disk subsystem where the data actually lives.
Uh-huh.
What do these things actually look like, though?
Right.
You know, physically.
Let's paint a picture.
Okay.
So, for smaller storage needs, you might encounter a system where all the disks are housed within the same physical enclosure as the controller. So imagine a relatively compact unit, maybe 2 rack units high. That fits into a standard server rack,
Okay.
like something from NetApp, for instance.
Okay.
Now, if you look at the back of such a system,
Okay.
you'll typically see a strong emphasis on redundancy,
Okay.
because these systems often hold business-critical data.
Right. You don't want any single point of failure.
Exactly. You want to avoid any situation where one component failing could bring the whole system down.
Right. High availability.
Exactly. And that's a key advantage over simple DAS.
Okay.
So what you'll often find on the back of a highly available storage system is dual controllers.
Okay. So 2 independent sets of brains.
Exactly. Working in parallel.
Okay.
So if one controller fails, the other seamlessly takes over.
Got it.
You'll also see redundant power supplies.
Okay.
So if one power source goes down, the system can keep running on the other one.
Okay.
And then you've got the network ports for connecting to your network, and potentially ports for connecting to those external disk shelves if you need to expand storage later on.
Right. Okay. So that's the back of the system.
Yeah.
What about the front?
So on the front, if you were to remove a cover,
Okay.
you'd see the bays where the actual hard drives or SSDs are installed.
Okay.
A system like this might hold anywhere from, a handful of drives to maybe 24 drives.
Okay.
Right there within that main unit.
Okay, so that can provide a pretty substantial amount of storage for many organizations.
Absolutely.
Okay, but what happens when an organization needs truly massive amounts of storage?
Right. Right.
Way more than can fit into a single chassis.
That's when things start to get really, really big.
Okay.
The fundamental building blocks remain the same.
Right.
You still have controllers,
Okay.
but now they might be housed in these much larger enclosures
Okay.
designed to hold more of them.
Okay.
And again, if you look at the back of these larger chassis,
Okay.
you'll see that redundancy again.
Okay.
You might have dual controllers, maybe positioned one above the other,
Okay.
each with their own set of power supplies,
Uh-huh.
and all the necessary ports for connecting to the network, and importantly, for connecting to those external disk shelves.
Right.
Because at this scale, those external disk shelves become absolutely essential.
Right, because you just can't physically fit enough drives in the controller chassis itself.
Precisely.
Okay.
So the controller chassis acts like this central management hub,
Okay.
connected to numerous external shelves that are just densely packed with disks.
Okay, so you can really scale this up.
Oh, absolutely. And it can get even bigger than that.
Really?
Yeah.
Okay.
For organizations with truly enormous storage needs, you can cluster multiple controllers together.
Okay.
So picture this. You've got maybe 6 entire racks filled with equipment containing up to 24 controllers spread across a dozen different chassis, all interconnected,
Right.
all working together as one giant, massive storage system.
Mm-hmm.
And then, of course, you've got all those disk shelves connected as well.
Right, so we're talking about a huge amount of storage here.
Oh, yeah, we're talking petabytes,
Petabytes.
potentially even exabytes of storage capacity
Wow.
that can be accessed by a vast number of users and applications.
Okay.
This level of scale and centralized management,